Hello everyone, welcome to Moonkids Tutorials. Let's discuss a new topic today. It's called Python fuzzy string matching. Now, where we can use it in the corporate industry, we can use it as a search engine. We can make a search engine out of it, and we can find out the closest matching words among the list of documents or list of words or any kind of a storage thing you have where the strings are stored. So you can use this one. Let's go start with the theoretical part first, and then we will move to the technical implementation of it. Let's go step by step. So what is fuzzy matching? Fuzzy matching refers to finding similarities between strings. It checks whether two strings are similar or different, and it also gives you a number between 0 to 100, and it gives you like how closely they match if it is close to 100, and if they don't match at all, it will be close to 0. Now, fuzzy matching is also referred to as edit distance. Now, what exactly this term means? This term means that how much does A string needs to be edited to match to string B. And now what editing operations it accommodates? It's over here, which is addition, deletion, and substitution. So what is this Levenshtein distance? Now, fuzzy string matching uses Levenshtein distance to calculate the differences between sequences in a simple to use package. Let's go on the next point. Maybe it'll become more clearer when we read this point rather than the first one. Now, it decides the similarity between two strings by computing the minimum number of single character edits. Now, this is very important to know. I'll repeat it again. It decides the similarity between the two strings by computing the minimum number of single character edits required to convert the first string to the second string. Now, what operations does it involve? Which is addition, deletion, and substitution. The smaller the number of required edits, the closer the two strings are. Now, let's go to the technical side of it and find out how we can use Python application to run. Now, how this technical implementation works, let's find out which Python version we are running. We are using Python 3.9. Now, installation involves fuzzy wuzzy and Levenshtein. It is already installed in my system, so it will do nothing. It will just show us that everything is already installed, requirements already satisfied. Now, going to the usage part, I'll provide you this Python Jupyter notebook. So don't worry about the code and all. But if you want to write it down, there are few lines only. You're free to do so. So going to the usage part, now we are importing two things. One is first, second is process from fuzzy wuzzy. We're not importing the whole module. So let's find out how these two things work and which one is better than other. Let's go by the first, and then we will use process later on. Now, simple ratio. Using the first, import first from fuzzy wuzzy, import first. Let's first start with a simple ratio. Now, simple ratio, did we run it? Okay, the simple ratio, it calls normal def-lib operation on two input strings. Now here, if you see, this is exactly the same string except the exclamation mark, but it takes care of everything, right? Spaces, letters, and order everything. So it is normally not used in the corporate industry, but if you your unit testing, you can do so. Why it is saying 97? Because we have exclamation mark. Now, if you remove it, it's gonna be 100. Now, the thing to notice here is if I remove the space also, it will not give me 100 because it takes care of each and everything. Letter, spaces, order, everything. So for learning purpose, you can say, yes, you know fuzz ratio, how it works, but I don't see much of use of fuzz ratio in the corporate world. Now, moving ahead, we have partial ratio. What is partial ratio? The partial ratio is basically picking up the shortest string and then finding that in the bigger string. Now it says, I study computers. I study computers in India. Now, if it matches the shortest among the biggest one, it should give me the highest rating, which is 100. Now, if I remove few words out of it, doesn't matter because the same string is there. It should give me the same 100. Now, if I change the order of it, this statement doesn't make any sense, but still we have testing it here just to find out how things works. See here, now if you see here, the orders matters a lot. But if I want to search something among a big, huge database, then I should not be worried about the correct sequence of words. In that aspect, I would say partial ratio is not much used, but it is relatively better than simple ratio. But I don't see much or use of this approach in the corporate world. Let's remove the spaces also to see how it behaves. If I do this, it will not give me exactly. Now, if I remove the last characters also, if I use the same characters and run it, see what it says, 94. So it takes care of the spaces also, which should not be the case. So let's move further. Let's do a bit of summary what we have done so far. We have used fuzz process from fuzzy wuzzy module. Simple fuzz is taking care of each and everything. Characters, spaces, order, not good to use further, but it's good to know how it works. Partial ratio, it takes care of, like, it picks the small string and find that string in the biggest string. If that string exactly matches, it gives me a 100 rating, otherwise it not. But still, it takes care of the spaces. I don't like it much. And if uh, it the worst part I would say is taking consideration of orders, which should not be the case. Now moving further in the token sort ratio. Now here, this I like as compared to the previous other one. The reason I'll show you. Now this is a FIFA fever going on, so I picked up the German team and the soccer team examples. So it says German team versus Argentina team, and I'm using all three things, all two things which I have read before, and this is a new one. So if we see this one, fuzz ratio, it takes care of each and every word and space. If it matches, it gives me 100 complete, but if it doesn't matches, then it gives me a low score. Now similar over here in the partial ratio, if I click this one, it gives me a low score because it matches, it has few words over here, but even if it is picking a shorter string than other, it is not matching because the order still matters over here. In the token sort ratio, the best is the strings out of order also considers taken into consideration. Now, if I consider this particular one, which is the last one, it should give me the highest one, which is 100. Why it is giving me? Because it doesn't care of the order. German team versus Argentina team, Argentina. Now, what exactly is happening? It is making a tokens of each word. Now, that token is then compared with one string than another, and if it matches completely, then we get 100. So we have seen how fuzzy wuzzy import fuzz work, and then we'll move on to process. Just a bit of a revision of fuzz, and then we'll start the process part. Simple ratio takes care of spaces, ordering, everything. Partial ratio, it searches a shorter string among the biggest string, but still it fails because here the order matters, which is a bit weird part. Token sort ratio, it for this particular thing, the order doesn't matter. Even if the words are in a different order in source and target, it gives me 100 if they both are same in both the strings. Now moving ahead, a process part from fuzzy wuzzy import process, what this does. I've taken an example of list of soccer clubs. uh, I have changed the name of the clubs a little bit to match the pattern over here and see how this works. Now, if I say here Manchester, now what exactly happens is I need to first import this one. Okay, no, the import part is done above, so if I need to trigger this one. And if I say here, now Manchester, now you see it gives me a different rating. And why it is showing me 4? Because I have given limit of 4. If I give limit of 2, it will give me 2 results. Now it will pick up this string among all the strings and it will give me the closest one with the rating also which matches closest than other. So if I do here 4, it will give me here. Now if I do FC here, just FC, what it will do, it will give me both Barcelona and Manchester as the same rating because FC exactly matches over there. Now if I do some spaces around, what will happen? Exactly same thing. So that means spaces doesn't matter over here, which is a good thing because it is a regular expression kind of thing. Once I give the string over here, this Python does its own part and will and just finds the matching patterns. Now if I see FC Barcelona FCF, so if I do YFC here, suppose YFC, then it will give me the closest matching one, which is Manchester City and rest above. Similar the case with FC, if I give bars and run. So see, the FC Barcelona matches closest, it gives me 90 and others are lower than this. Moving to the next step, now here extract one. Extract one, give me only one. And here with the limit option, I can control the output from 1 to the number of limits I provide. Now moving further, there is a Jaro Winkler also. What exactly is Jaro Winkler? Let's see about it. Now Jaro Winkler distance algorithm was proposed in 90s. Now it builds upon Jaro similarity algorithm. I'm not going to show you exactly the whole formula behind it, but this is also a good thing to use in the corporate industry. Now what it does is it is a bit of difference than compared to the fuzzy wuzzy because the fuzzy wuzzy rating was from 0 to 100. Now this rating is from 0 to 1. Now what it does is the first step to calculate the Jargo similarity is to count the characters, not the words. Count the characters that match between the two strings. And then these characters do not need to be in the same place in both strings. So good to know, the ordering doesn't matter. Going back to our Jupyter notebook, if we're gonna install this, it would do nothing because it is already installed. Now here, I'm importing Jaro. I'm giving the exactly same string. So idea is to get the highest rating, which is 1. Now, if I remove a part of it over here, and it gives me less than 1 because not everything matches, which is 0.8. One thing to find out here is that it says it picks up the characters. Going back to our PPT, the characters to count the characters that match between the two strings. Now, if I just write down some other statement, I am going to Goa. Now, if I do this, it will not be 0. It will be 0.6 or anything greater than 0 because there are certain characters over here, alphabets, which still matches. So if you see here, the ordering doesn't matter. Exactly the whole words are not picked up as tokens. It is playing with the number of characters and the characters themselves. So if I compare both the things like Jaro and Fuzzy Wuzzy Fuzz, I would say I give slightly more weightage to Jaro Winkler as compared to Process and Fuzz, but it depends on your technical implementation, what you want to achieve and what is your requirement. So I leave it up to you guys to decide. Thanks for watching Moon Kids. Please like and subscribe our channel. Thank you.